Hello everyone. In our second video on CoppeliaSim, we are going to talk about three other properties of objects. Remember in the first video, we talked about the static versus dynamic and basically respondable versus non-respondable. So you can see them here, right? So now we're going to talk about three other properties. So here I have created two primitive shapes, cube 1 and cube 2, where cubic 1 is on the floor, cubic 2 is going to fall onto it. And I have a Kinect as well as a proximity sensor. So the properties we're going to talk about are collidable, measurable, and detectable. So what are these? So if you remember, the property that we call respondable means that the object will respond to the collision forces or the forces from another object. And if both of them are respondable, then they can affect their normal forces, the contact forces will affect the motion of the other object, okay? Now, if the object is collidable, means when two collidable objects will collide each other, will hit each other, then you can basically get a collision status or state. So you can detect the collision. You can detect whether a collision has happened or not. That does not mean they would respond to the collision forces. So collidable and respondable are two different things. Collidable just means that you allow the system to check whether these two objects had a collision or not. But it doesn't mean they respond to the forces from each other. So respondable is one layer above that. So if you want to check whether two objects hit each other or not, you can do a collidable property. Detectable means the presence of the object is detected by proximity sensors. And measurable means you can measure the minimum distance between the objects. For instance, two objects like these, or could be a part of the robot with the rest of the robot, or anything like that. And you can learn about these properties if you just go to the help or user manual by Coppelia. You can see these are the collidable objects, right? Registering a collision state. And then we have measurable, that, as I said, you can calculate a minimum distance of one object against another one, as long as they are both measurable. And we have detectable, that means they can be detected by proximity sensors. So here, I'm going to show all of them to you. And the reason I added this Kinect, I wanted to tell you that, hey, this Kinect, as you know, is not really a proximity sensor, although it has depth. And when you say it's detectable, that doesn't mean if it's not detectable, then you cannot see it in the Kinect. You still can see it in the Kinect, but you might not be able to measure the distance of it in the proximity sensor. So the Kinect, as you can see, these are the Kinect. This is the RGB and this is the depth part of it. You can see them very well. And if I go and turn the measurable properties of them off, you still should be able to see this depth map. So what I want you to see here is this yellow line here. That means the object is within the range of this proximity sensor and it can detect it. And I'll tell you how to change that range. Right now, the range of this object is about 1 meter. So the distance from this cuboid to this object is 0.4, so it is well within the range. And as you can see here, let me pause this, you can see that the distance to the proximity sensor is 0.4, and I'm showing it on the screen here. How do I do that? Using these scripts, and I'm gonna go with you through these scripts. Although I'm gonna have a separate video on creating scripts, but I just want to show you what is it that we are doing over here. And by the way, the contents of these three scripts, I'm going to share with you as 3 text files under the video description. So if you want to try that, you can do it yourself. And as you know, the CoppeliaSim, the educational version, is free. So feel free to just download it as long as you are a student or professor at the schools or universities, and you can learn from this great software. So here I have these cuboids. You see I activated all those three properties. I have this connect that I just added for demonstration. Now I can go ahead and get rid of it. And let's talk a little bit about this proximity sensor. So how do you add a proximity sensor? You just right click here and then say add and then say proximity sensor. And there are different types of proximity sensors, different kind of shapes of the rays, whether they are pyramid, cylinder, disc, cone, or something. Okay, this guy, I think it was a cylinder one. Yes, and then there are different technologies. There are ultrasonic, there are basically you have infrared and different lasers and all sorts of things. Okay, so there are different types. And then, as I said, if you double click here and bring this window, now you can see that basically, let me first stop the simulation. There we go. So I can look at this with you. So you see here that if I go under proximity sensor, one is volume parameters. So you can see basically the range of the sensor. So here I changed the range to 1 meter. Originally it was like 0.2. And then I can have basically an offset that you can see from the rays to the sensor, and then angle and everything. And then I can go to here, for instance, I can say don't detect anything as long as the objects are smaller. The distance to the object is smaller than that. So right now you can just bring them almost at the sensor and the distance is like 0, still detected. Many sensors are not like that. They have a range something like, I don't know, 5 centimeters to 1 meter or something. So they have a minimum and a maximum range. In this case, we only have a maximum of 1 meter. But if you want, you can basically activate that and put a number for that over here to make it more similar to your actual thing. Then you can have different colors for this volume, right? And then the color for the sensor, the color for the rays and everything. But the most important thing I would say is this minimum distance and this maximum distance, really. So this is my sensor. And as I said, when you see that yellow line means it is doing its work and it is detecting something, okay? So if I go ahead and move this cuboid away from the sensor, right? So right now the x coordinate is 0, but if I go, or y coordinate, if I go ahead and put it at 1, right, out of the cylinder, so now you can clearly see that. Let me show you. So it is out of the cone. If I go ahead and simulate this, it is going to show 0.2, and this 0.2 is actually this object here, right? But if I go ahead and make this object static, so let me go to this object and make this object static, so it doesn't move. Okay, now you see it is showing 1 meter, while 1 meter is wrong because this distance is more than 1 meter, right? This distance is clearly more than 1 meter. And to show you that it is not really working, I clicked on this cube and I move it to basically, let me show you. So here, basically my y coordinate, I'm gonna change it to 1.5. Okay, so now the distance should change, right? And you see it doesn't, it still shows 1. So clearly it is not working because my range is 1 meter. So now I'm gonna bring it back and I'm gonna show you the collision and the rest of the code. So first thing first, how do I read the number from the proximity sensor? So let's go ahead. So here I right clicked on the proximity sensor, then say add, then say give me a script, a simulation script, non-threaded, and there are 2 languages that you can write, Lua and Python. And here I made it in Lua, but you can make it in Python, okay? So they're quite a bit similar. So here, this is that code here, right? And if you go and look at it, in general, any script, if I show you, let me show you. So I'm going to add another script here. So you see the overall structure of a script. Look. So script really has four major functions. And again, we're going to talk about it in a separate video. The first one is initialization. So you bring the sim so you can get different objects for the sim, right? And then here is if you have any actuation in the system, if you have any sensing in the system, and then a cleanup of the resources. Okay, and you don't have to have all of them in a code. The initialization is typically always needed, but these three are not necessarily. This last one is good to free resources, and these two depend on whether you're doing it for a sensor, actuator, or for the whole thing. Okay, so right now, let me just get rid of this and go to this proximity sensor script. So you see here, all I have is an initialization and sensor. I start the sim, and then I get the handle for the proximity sensor, which is the name of the sensor. I also have a time here, a time counter, because I only want to show the results, the minimum distance every 2 seconds. So I also need get simulation time and to keep track of time. And if time has passed every 2 seconds, then I'm gonna get the reading from the sensor. How? Using this method called read proximity sensor. So sim read proximity sensor, and then sensor handle, which is coming from the name of the sensor. And this will give me two variables. One is result, one is distance. And I call them both local variables. If the result is 1, means the sensor actually read something, then you're going to print that the distance to the sensor is, and then you're going to format the distance in a 0.4f, which means floating format with 4 decimals, and in meters, else say no object is detected, and update the time and keep going. So that's all it is. The real thing is this guy here and defining the sensor. Okay, and this result, that if it's 1, that means you could read something, otherwise you couldn't. So this is the proximity sensor. Now, let's talk about the collision. So here, if I show you, let me run the code. And you can see that if I go up a little bit, you see it says that initialize collision check between cuboid 1 and 2. And then as soon as they hit each other, it gives you this message that collision started between them. So how does this code work, which I added it under cuboid 1? So here you can see again, I'm starting the simulation. I get the object cuboid 1 and cuboid 2. And if any of these two objects I cannot get, go ahead and throw an error message so I know that I got something wrong here. Okay? Yes? And if you want, you can get rid of this portion. You don't have to have this portion. This is just a check. And then here, go ahead and say that it is started. Initially, I assume that the collision is not happening, and then as soon as it does happen, I change this false to true. So this is my flag, this is my Boolean operator. And then here I have my sensor again. I say if these objects are not really detected, go ahead and return. Again, you can get rid of this if you want, but here we are keeping it for robustness of the code and the fact that we don't want it to throw error. And then the major thing is this sim check collision. Remember, when you make them collidable, now you can check the status of collision. You pass to it the handles of object 1 and 2, and it returns the variable colliding, which is a logical variable. If it's 1 and there was colliding, before that it was false, so they were not colliding, but now they are, go ahead and say collision started. Otherwise, if you don't have a collision, but you had already a collision and the collision removed, say collision ended. In this case, it never happens. This scenario 2 never happens because the top cuboid falls down on the bottom cuboid and then basically stays there. But if I moved one of them a little bit away, so when it falls on it, then it topples over, then it will also show this scenario and say, hey, the collision is ended. Okay, finally, we want to check the minimum distance between these two objects and show it. And here you can see it is going to show that, right? It shows the minimum distance. And when it says minimum distance, it's really from center to center. It's not from surface to surface. So you see it shows a minimum of 0.4 because the dimension of these boxes are 0.4 by 0.4 by 0.4. So center to center is 0.4 here. Again, it's not surface to surface. And the way that you do that in this code here is, again, you get the handle of these objects in the initialization. And then in the sensing, you need to just use this method called check distance. Give them the object handles. It returns a result and a data. And if the result is positive, means it was able to detect the minimum distance. If it is, then go ahead and basically show that data with a specific format and basically go ahead and show it on the screen, okay? And that is what you can see over here. So these are 3 scripts that I added for the sensor and for these objects. And again, we're going to have a separate video. We're talking about the basically scripts a lot more. We're going to talk a little bit more about the simulation versus customization, non-threaded versus threaded, and so on. But here I wanted to talk about measurable, collidable, and detectable properties for the objects. So hopefully the video was useful to you. I'll see you in the next lecture. Thank you.